Welcome everyone. As we discussed in the previous class uh, about some polynomial function, how it will look like if we draw the plot. So here in this class, I will be talking about various examples from taken from chemistry and try to plot those. Okay, so let's start into that. So in the last class, we ended with y is equals 1 by x 1 by x squared. How it will look like. I hope you have understood it. If you don't, then go back to the previous section and see it. Okay. So these two we know already. So let's just try with the examples. So you all know Boyle's law, and we have also seen it in case of straight line as well. Now what Boyle's was saying, it is v averages 1 by p, right? So you can do v is equals k by p. K is equals constant. What is Boyle's law? At constant temperature, volume of an ideal gas will inversely vary with its pressure, right? That is the Boyle's law. So now, if it is asked like how you can draw V versus P, right? Or you can draw V versus P. So just by looking at this equation, you can connect it with with previous class where we have drawn y is equals 1 by x, right? Where y is equivalent to v and x is equivalent to nothing but the v, right? So this is my this will be my plot. So how it will look like? We already said just compare it with y is equals x. So because they are not asking, so you just draw this imaginary line. You just don't while practicing for now, you will draw this and then draw it. But otherwise, you will imaginary in your imagination you can think about it and then draw it. Let's say this is your point. This is where it is 1. So it will obviously intersect, and the plot will intersect y is equals x at x is equals 1. So from this, and now whenever, let's say from the perspective of this, whenever p is tends to 0, that time v will be, that time p will be what? V to infinity, right? And whenever p infinity, v is equals 1 by infinity, that means it will be 0. So in this one, it will be like this. In this one, it will be like this. So pardon my bad handwriting as always. So how it will be? Right? So this is your plot. So this is very simple. Just from the previous class analysis, you can directly draw it. Right? Now go to the next example. So let's say for Charles law. Is it? And I'll be taking various examples. It may be a polynomial. And let's just what is Charles law? Say v values t. That means v is equals kt. These examples has already been taught, but I'm just again doing it just to remind you. So this is nothing but a straight line. If you draw v versus t, nothing but a straight line with the intercepts. So that means it will start from this point, right? And the slope will be how much? Right? Now go to the next example. I have written down some examples and just going one by one, right? So let's say this is for simple harmonic cylinder. right? So what is simple harmonic oscillator? It's nothing but pendulum is hanging from this by a string of weightless string, right? So it will go like this, right? So these two are the position, or maximum position, and this, right? This is the simple harmonic oscillator. Or you can think of a spring, right? Depending on this. So if you अगर तुम इसको खींचो, so what will be the restoring force? By Hooke's law, it will be minus kx, right? X is the displacement. So this will be F is equals minus kx, right? Because F will be proportional to the displacement, right? From Newton's law, you can write it down by F is equals minus dvx by dx, right? dx into minus f into dx. If we integrate it from 0 to vx, this will be 0 to x. So what we will get? Vx is equals fx, right? Minus f. Now here we have done a mistake. What it is? We know f. F will be minus kx. So you cannot do it like this. You need to do it like minus. Because f is not independent of x, right? What is the expression of f? That is minus q. So it will be k x dx pardon, it will be nothing but 0 k x dx integration 0 to x, right? So what it will be? Half k x square, right? K x is equals half k x square. So this is your y, or rather fx is equals half k x square. Now if we need to plot Vx versus what? X. How it will look like? That is the question. So how it will look like? So this is nothing but, this function is nothing but y is equals a x square, right? Yes. That half k, this half k is nothing but a constant. So I'm considering it as a. This is a x square. So we know y is equals x square part. How it will look like? Y is equals x square part. In the previous class, we have already talked about. Let me go back to that. You understand. So this is your y is equal to x square. What will you do with this? Right? So it will be like a parabola. So this plot will also be a parabola because this is only on a constant. So if we draw it, right? If we draw it, how it will look like? It will look like just like this. This is the plot, right? This is minus 1 plus. Whatever it is, minus or plus, this is a symmetric function, sorry, even function. That means we wanted to know that is symmetry about y is equal y axis. That makes it interesting. Okay. We already discussed it. Now let me go to another example. That is nothing but black body radiation. This thing, if you don't know yet, you will know whenever this will be taught in the class, right? Black body radiation. This is introduction of this will be the introduction of quantum chemistry class. So black body radiation is famous and it is given by Rayleigh gene. Okay. So what they have given, the energy expression or energy density, how the energy density will depend upon frequency. So let's say this energy density is rho mu, right? So it will be 8 pi k t square by CQ. Right? If you want to plot this rho versus output, is nothing but y is equal to x square. So this will obviously be right. Right now, you can directly go rho mu to rho lambda because you know the relation, right? You know the relation. So lambda is nothing but c mu is nothing but c by lambda. That means it will be 8 by kt by c q into c by lambda whole square. And d mu, if you want to change it in terms of lambda, then it will be c by lambda square into d. So if you simplify it, it will be 8 pi kt to the power 4 d. Right? Okay. So if you want to know how we are getting this d mu is equals c minus lambda, sorry, minus c by lambda square d. So here it is. So mu is this. So if you want to do d, that means it will be c as it is. And this one is minus lambda to the minus 1. That means there will be 1 minus by lambda square. Because it's the derivation, simple derivation. Right? So here, this here. So this is what the expression we are getting. This is my rho. Right? So now if we want to draw this, it is lambda. Very easy. So we now y is equals 1 by x, and y by x square, 1 by x cube. So this is similar like this. So how it will look like? This is your lambda, this is your rho lambda. So that means this function is like rho lambda is some constant c by lambda equals 4, right? Y is equals 1 by x to the power 4. So if this is your 1, this is x is equals 1. So at this point, this is cut obviously by y is equals 6. That means this will be like. So at both the point 0 and infinity, the function will be 0. So at 0 it will be infinity, and infinity x is equal to infinity, it will become 0. Similarly, like y is equal to x. So the function will be like somewhat like this, right? It's very easy. Profit. Now, if we know a little bit of electrochemistry, so there's the equation that is for equivalent conductors. And for weak electrolyte, this conductor lambda. So for unique electrolyte, this is expressed as lambda is equals K by root C. So you can write it K by C to the power half, where C is the number of the concentration of the electrolyte, right? So if you want to plot it, what it is, lambda, that is root C. If you want to plot it, lambda has a root C itself. So this is nothing but lambda into root C is constant. This will be again like this. At x is equal to 0, this will be infinity. At x is infinity, this will be 0. And these kind of structures are called hyperbola. Hyperbola. We know y is equals x, straight line. We know x square is parabola. 1 by x hyperbola. Okay. This is the hyperbola kind of structure. Whenever this y and x will give a constant, this kind of structure will come. Right? Now, if it is y is equals to x square or x cube, the structure will be similar, will be same. But if you compare it with y is equals 1 by x, then only you will know at 0 to 1 point it will be greater value, will be at 0, at greater than 1, it will be similar lesser value. Like in the last class we have discussed on it. Right? So this is very easy how to plot with lambda equivalent conductance with concentration of the electrolyte. Or remember, this is only for weak electrolyte. These basic things you will learn whenever the due courses will come to learn. But for a strong electrolyte, for a strong electrolyte, this equation is somewhat different. That time this is called as lambda is equals lambda 0 minus K root C, and this is known as very famous Roche. This law, right? This is given conductance for strong electrolyte. So now, if you want to draw lambda versus how it will look like. So don't need to worry. Just go back to your first class, right? Go to first class numbers. We know a equation of straight line. That is y is equals mx plus c. This is somewhat looking like so, right? What is lambda 0? That you need to know first. What is lambda 0? Lambda 0 is nothing but equivalent conductance at finite dilution. तब dilution बहुत ज़्यादा है तब जो conductance मिलेगा that is a constant and that is called equivalent conductance at infinite dilution. So lambda 0 is basically nothing but a constant. So now if we compare it, so we will get your y is equivalent to lambda equals to plot. Whatever you need to plot with, and whatever you need to plot is y, and with respect to what is your x. So your x is nothing but c, right? So what is your in? So it is not root c, okay, right? You see, this is sorry. So x is your root c, right? Now you want to plot it. So what will be your slope? That is m. What will be? It is nothing but minus k. So now just very easy. So this will be like this. So so is there any problem with the plan? Is there any? Can you understand? So just pause the video here and try to think. But there's a big blunder. I intentionally meant what it is. Repetitive. The slope is minus, right? It cannot be this because we know slope is the angle made with positive x-axis. So obviously this will be nothing but right, and this will be the angle. Now this is around this is also right. Okay, so you need to keep this thing in mind. Whatever you are learning, you need to keep it because you cannot do such silly mistakes. Okay. So you can do this plot in a different manner as well. So what do we call lambda is nothing but lambda minus k root c, right? So you can do it like if you want to do lambda plus k root c is equal to 1. Now we know one more straight line equation is this. And this is a bit easier because here you know exactly what will be the intercept at x-axis and at y-axis. So if you try to write it in form of that, so it will be lambda by lambda naught plus k by lambda naught to c is equal to lambda by lambda naught plus root c by k. So if we draw this plot, so what will it be? It will be nothing but like this. This is my y-axis, this is my x-axis, this is my y-intercept, this is my x-intercept, this will be lambda by k, this will be right? From them, so let's say let's think it from experimental chemical perspective. So if you measure the given conductance at various concentration and plot it, so from both the intercept you are going to get your lambda naught by, right? Your this lambda is lambda naught by 3. This is your lambda naught. So you're going to get what is your lambda, right? Okay. So let's go. Let's go to some different kind of function because we have learned about various polynomial function and we'll take several examples. So now we will learn one of the very important function that is exponential. And this is maybe one of the most used function in case of chemistry. So exponentials is one such any kind of relaxation, okay, like any kind of it will be some kind of exponential function or simple exponential function. But this will be exponential function. So exponential learning exponential function means plot are very important. So let's just start with y is equals to x. So e is this exponential. What is the value of e? You know what is the value of e? Is just a series, okay, series of various functions. So p is equal to internet x plus x square. So we're going to have 1 plus x plus x square by 2 factorial x by 3 factorial. So let me ask one question. Is this function even or this is neither even neither odd type of function? Because if you think about x, this is odd, this is even, this is odd, and the certain next one will be x followed by 4i, this is again even, so odd, even type. So this is neither even function, neither or odd function, right? So this is also basic thing. So now let's concentrate on how the plot will look like y is equals e to the power x. So how exponential or an exponential function? Let's just do this. So this is y-axis. Now this is thing y is equals to x, right? Now for this kind of function, you need to think like this. What will you need to have 2, 3 values? Then you can have an idea. You can have an idea of how to do it. So let's say at x is equal to 0. What it will be? Y to the power 0. So anything to the power 0 will appear to be right. Now think about x is equal to infinity. Right? So what will be let's see this. This is a ever-ending function. Now putting that never-ending function and you are putting something to the power 8. So it will obviously be given value of infinite, right? Because there is no chance x is in the always in the numerator. So 1 by infinite is that is 0. But this function, if we put to the power infinity, so it will obviously be infinite. So at x to x in 0, whenever x is 0, that time you are getting 1, and at x is plus infinity, you are getting the value that is equals to infinity. So now it's very easy. So you got to find. This is your one, let's say, and whenever this is like this, so it is ever increasing, always increasing. So this is like this, right? So this will always be increasing, always be increasing. Now let's say x is equal to minus infinity. How it will be? X is equal to minus infinity, y is equal to minus infinity. You can think of y 1 by 2 by infinity. That means we know the infinity is infinite. So 1 by infinity, that means 0. So at infinite value of y inside x, it is 0. So this function will nothing but like this. So at minus infinity, this is 0. At plus infinity, infinity, and at 0 times 1. Similarly, if we try to do e to the power minus x out to p, it's also very similar kind of function. Now let's just put same values. So at x is equal to x is equal to 0, what it will be? 1 is equal to 0. So minus equal to 0 is same. So, but anything equal to 0 is 1. Now at x is equals to infinite, how the function will be? Function will be e y is equal to the power minus infinite. Now we know the 1 by e to the power. That x is equals minus infinity. This will be different. And to the power minus infinity. So and this. So how the function will look? So how function will look? you find that one. At this point, this will at 0, this will be now 1. But whenever you are going to approaching infinite, x is equal to infinite, this function will be 0, right? At infinite, this will be 0. But at minus infinite, this will be 0. So this will be your function. So how to do for next? Right? This will be your okay. So this plot normally generally called as detail. It's like from a value, to 1, from a value, it is decreasing and becoming 0. So any kind of excited state process or any kind of thing dealing with population, we looking like this, e to the power minus x. It is very, very important thing. Now, if you think a very interesting plot, that is y is equal to minus mod x. Okay. Think about it. Why? What do you know? What is x? Mod x is x whenever x is greater than 0. And mod x is minus x whenever x is less than 0. Okay. That means this is always positive. Always positive. There will never take a negative. Now think about this function. At x is equal to 0. Again, 4. Now think about x is equal to minus 0. Right? So what will be y is equal to minus? So from mod, it will be always be positive because it will be minus x. That means e to the power minus of minus infinity, right? So why it will be equal minus plus infinity. So now this is equal minus infinity. So what is equal minus infinity? This is nothing but. Now think about other things. Whenever x is equals plus infinity. So why will be nothing but minus infinity? From 1, it will be positive minus infinity. So now if you want to draw the plot, so at 1, this is obviously having a value of 1. But at minus infinity also this is like this. Sorry, plus infinity also this is like this, and right. This is very interesting. You know, all the negative part, sorry, all the infinite part, whenever it was the minus x, it was like that. Plus x, it was like that. So these two parts are missing in this part. So now this is not like this is a you can say this is a function is under limit. Like it will always give a value. So whenever it is having a boundary, right? So why it will come? When it will come into handy this knowledge. So in case of quantum mechanics, whenever you will read it, that time there is a very basic thing you will learn there is why when a function, quantum mechanical function, or when a function will be quantum mechanically acceptable, right? And when it will be acceptable, there are some two things criteria. One is single value, one is first derivative needs to be continuous itself. It needs to be continuous. Never it will become infinite. So it will go minus x and it will plus x are not quantum mechanically accepted, but there is a chance that it will minus mod x will be quantum mechanically accepted, right? So this is a um, very important discussion. So this is very important. It will be a minus one. So now, if I ask y is equals to the power minus y, is this function even or odd? Let's just do it. So what we say, f minus x is equals fx. If this is the case, then what it is, right? And if f of minus x is equals minus of fx, then this is odd. Now the question, it will be power minus x. Is this odd? Right? So check this. Minus x. So for more, if it is minus, it will come as positive. If it is positive, it will come as positive. So it will go minus, it will come as, it will come as, it will go minus, this minus it will become minus. So this will be minus minus x. Okay. Right. Because if you take more minus, it will become positive. So it will become this. And in case of positive as well, it will obviously become, if you take fx, then this is this. Right. So here it is coming out as x. So you can say directly it is to the minus of x. But here it is already chosen fx and f minus x. Then this function is a function. So what we already learned, the function will be symmetric about y-axis. Is it so? Right? So that's it. So we'll do one more example. What it is. Let's say y is equals to the power minus x. How the plot will be, right? Similarly, we just do it at x is equals to what will be the value of function to the power 0. No doubt about it. Now x is equals minus x square will be infinite plus infinite, right? So e to the power minus infinite 0. And at x is equals plus infinite, x square will be obviously be infinite. So at both the point, this is at both the point, this is 0, minus infinite plus infinite. But at this x is equals 0, this value is 0, right? So if we draw it, this will be like this. Next, this is 0. And whenever we are thinking about, whenever we draw e to the power minus mod x, this was like this, right? This e to the power minus mod x. The back one to the power minus x. Why it is so? Why it is not? Like how it is coming this? Because whenever the value is greater than 1, that time obviously like this will not be like this. So how you can draw both the question is how the question is how you can draw both the plot in similar both the plot in similar in a similar graph. How you can draw them both the okay. It's nothing but now x square will be like that at infinite is 0, at this is 0. So whenever this is 1 plus minus 2, that time is to go like this and this. So this is like a basic graph. Right? Okay. So the first one. So this. Okay. Now, let's do one more example. That is, if it is y is equals to the power 2x minus this will be exactly same, but at because at y is equals to 0, so at x is equals to this function will be 1. At infinity, this will be 0. Minus infinity, this will be 1. Okay. So these are some examples of exponential function. Now, in the next class, we'll learn how polynomial plus exponential function can be. What do I mean by that? If a function consists both polynomial and exponential, like y is equals x to the power minus, how will it work? Well, this will be the case for kinetic reaction, nuclear reaction. So this is very, very important. We learn this in the next class, right? How we can draw a function having both polynomial part and exponential, right? So I finish the class today here, and see you in the next class. Thank you for listening.